Hello students, welcome to this lecture. So in this video we are going to see a problem. So here a problem statement has been given. A 3300 volt star connected synchronous motor has synchronous impedance of 0.4 plus J ohm per phase for an excitation EMF of 4000 volt and motor input power of 1000 kilowatt at rated voltage. Compute the line current and the power factor. So here the synchronous motor has been given. Synchronous motor having the voltage line voltage. So line voltage given was 3300 volt, and it is having a synchronous impedance of 0.4 plus J5 ohms, and the excitation EMF, that is EF, which is given as 4000 volt. This is also a line value because this is a star connected motor. And the motor input power, which is given as 1000 kilowatt. So we need to find out what is the at rated voltage, what is the value of the line current and the power factor. So in order to find out what is the line current and the power factor, we need to find out the value of IA at first. So before IA we need to find out what is del, because from the power triangle diagram, the IA, ZS and EF and VT, we can apply the cosine rule over that particular triangle, since we have studied those triangle in the previous videos. So from that triangle we can find out the value of IA. So by that method we are going to so VT, the line voltage has been given as 3300 volt. Since we need to use the per phase values, we will be dividing this by root 3. So the value will be 1905.3 volts. And the EF value, the excitation EMF, which is also given as 4000 volts, that is also to be converted into per phase value. So the per phase value will be 2309.5 volts. So this has been found out. So next we need to find out what is ZS. That is another parameter which we need to find out. So we can find out from the value which is given as 0.4 plus J 5 ohms. So 0.4 square plus 5 square. So the value will be 5.016 ohms. So from that we need to find out the another angle, that is an impedance angle. Impedance angle can be found out from this particular impedance value itself. So theta z will be tan inverse of x by r. So what is x? X is going to be 5 and r is going to be 0.4 from that we can find out the value of theta z is going to be 85.43 degrees. So the per phase power input value, the power input can be found out from the formula Vt square. This formula is also we have derived already. Vt square divided by Zs square R minus EF Vt divided by Zs to cos theta Z plus del. We know the power input value, that is going to be 1000 kilowatt. So 1000 into 10 power 3 divided by 3 because this is a per phase value, because this formula has been derived for per phase value, but in the problem we have been given with for 3 phases, so we will be dividing it into 3. So Vt, which is already found out, like 1905.3 square. The Zs has been derived as 5.016 the whole square into R is going to be 0.4 minus the EF will be 2309.5 into Vt is going to be 1905.3 divided by Zs is going to be 5.016 into cos theta z is 85.43 minus this del. So we need to find out what is this del. So we shall find out each and every values. So this value, and we can make this value from here to this side, and we shall find out this value and divide this whole values divided by this particular value. So we can find out from that calculation that cos 85.43 minus del, which is going to be equal to, sorry, this is going to be plus del, so plus del is equal to minus 0.314. So you can verify this with your calculator, so you can do it on your own. So the power angle that is calculated from this particular value, that is making this particular into cos inverse of this value and making this 85.43 to be negative on this side. So by making those calculation steps, we can find out the del value as 22.87 degrees. So we need to find out what is the armature current. The armature current, as I have told before itself, we can find out the armature current from the phasor diagram which we draw for EF, VT and IA ZS. So from that particular diagram, so by recollecting that that particular diagram, we can come to the cosine formula for that particular phasor diagram. So IA is equal to EF square plus VT square minus 2 EF VT into cos delta. So this whole term will be given as root. because here IA Z as the whole square will be coming. So since we need to find out this IA, we will be making the whole root upon this particular term. So EF will be, so at first the IA into 5.016 is equal to root of EF will be, so EF will be 2309.5 the whole square plus 1905.3 the whole square minus 2 into 2309.5 into VT will be 1905.3 into cos, the delta value is going to be 22.87. So if you calculate these values and making this particular value to be in denominator, we will be getting the IA value as 184.43 amperes. So for this particular problem, we have found out the half of the value. That is, it has been asked that to find out the armature current and the power factor. We have found out the armature current now. So to find out the power factor, we will be having the per phase power equation Vt Ia into cos phi, which is going to be the power value. That is, the power value of the machine will be 1000 kilowatt. That is also per phase. So 1000 into 10 power 3, that is 1000 kilowatt. Since we need to have the per phase value, we will be dividing it by 3. So the cos phi is going to be, that is, this Vt and Ia should also be as per phase values. So we will be having this 1000 into 10 power 3 divided by 3 into the Vt value will be 1905.3 into Ia value will be 184.43. So we can find out from this particular calculation that the cos phi will be 0.9484. So first we need to have this particular power factor is either positive or negative. So we know that if the Vt is going to be greater than the EF, then it is going to be lagging power factor. If EF is going to be greater than the Vt, then it is going to be leading power factor. From the idea of the before calculation, that this is going to be our Vt and this is going to be our EF. So from this we can find out that EF is greater than Vt. So from this particular point of view, we can come to that this particular machine is having leading power factor.